This video is about goal 3, actually goal 4. I think I just repeated goal 3 in the workbook, but it's about factorizing quadratic trinomials using product sum. So that's a lot of words. Quadratic is something that's squared. So a squared is part of a quadratic because it is squared. Trinomial means that it has 3 terms. So up until this point, we've really focused on things that have 2 terms. Trinomials have 3 terms. So all quadratic trinomials follow the pattern ax squared plus bx plus c. And you'll see this a lot as we move up through our years in math. But really what we're saying is this is what you get when you FOIL. A quadratic trinomial is what you get when you FOIL 2 brackets that have 2 terms in them. So when I FOIL out x plus 2 and x plus 4, and I won't show you the result of that foiling, but when I FOIL that out, I'm going to get x squared plus 6x plus 8. This expression that I get right here is a quadratic trinomial. It has a squared term, and that is one of 3 terms that it has in total. Quadratic trinomial. So quadratic trinomials can be factored into 2 brackets, just like these ones up here. So remember, factoring is the opposite of expanding. So it's what we get before we FOIL. So when a is 0, that should be a equals 1, sorry. When a is 1, many quadratic trinomials can be factored using the product sum method. So when this coefficient here is 1, we can use the product sum method to factor those quadratic trinomials. You'll learn methods for dealing with situations when a is 2 or 3 or negative 3 or 15 next year. But for this year, we're only going to look at quadratic trinomials whose coefficient on their first term, their squared term, is 1. In order to do that, we use the product sum method. And in order to use that method, we have to get really good at identifying patterns in numbers. So these first 2 examples are just lead-ups to what we're going to do next to actually factorize these quadratic trinomials. But if I'm looking at the first example, I need to find 2 numbers, same 2 numbers, that have a product of 24 and a sum of 10. So you'll remember that product means multiplying. So 2 numbers that I can multiply together to get 24. And the same 2 numbers have to be able to be added together to get 10. So if I'm looking for 2 numbers that multiply to give me 24, and the same 2 numbers have to add to give me 10. Oops. Some people will find this really, really easy. They'll look at this and they'll make a mental list of all the factors of 24 in their head, and they'll have no problem doing this. Some people will find it hard, and for those who find it hard, I would recommend that you make a list of all the factors of 24. And remember that factors are numbers that multiply to give you 24. So those numbers could be 1 times 24. I could also have 2 times 12. I could have 3 times 8, or 4 times 6. There's no other factors there of 24. Those are numbers that multiply together to give me 24. So these are all my options for my 2 sets, or my sets of 2 numbers. Only one set here is going to add to give me 10. And I'll give you a second to think about that. But if I need to add these 2 numbers instead of multiplying them to give me 10, the only set that works is 4 and 6. So 4 multiplied by 6 gives me 24, and 4 plus 6 gives me 10. So 2 numbers that have a product of 24 and a sum of 10 are 4 and 6. In this second example here, we're getting a little bit more complicated because we have a negative. So we need 2 numbers that multiply to give me negative 12, and those same 2 numbers have to add to give me negative 1. So some of you, again, will come up with this right away and have no problem. Some of you will need to make a factor list, and I encourage you to make a list based on positive 12 first and deal with the negative after. So factors of positive 12 are 1 times 12, 6 times 2, and 3 times 4. So now we have all of these options because this 1 times 12 could either be negative 1 times positive 12 or positive 1 times negative 12. So we have actually another set of options. We could have negative 1 times positive 12 or positive 1 times negative 12. Same thing for 6 and 2. We could have negative 6 times positive 2 or negative 2 times positive 6. We could have negative 3 times positive 4 or positive 3 times negative 4. So looking at that, do you see a set here that you could add together to get negative 1? All of these will multiply to give you negative 12, but we also need those numbers to add to give us negative 1. Do you see any examples here that would add to give you negative 1? 3 plus negative 4 would definitely add to give me negative 1. So those are our two numbers here. 3 multiplied by negative 4 gives me negative 12. 3 plus negative 4 gives me negative 1. So my two numbers are 3 and negative 4. This is an important skill for our next step. So if I want to fully factor this quadratic trinomial, x squared plus 3x plus 2. Step 1 says find two numbers that multiply to give you c and add to give you b. It's important to remember here that c is our constant term. Constant terms are terms that don't have variables, they're just numbers by themselves. So c here is 2. B is the coefficient of x, not x squared, just x. So it's going to be our middle guy right here. So our b value is 3. So our two numbers need to multiply to give me c and add to give me b. So they need to multiply to give me 2. And the same two numbers have to add to give me b, which is 3. This is an easier example because, sorry guys. This is an easier example because there's only one set of factors for 2. It's a prime number, 2 times 1. And if I look at those factors, 2 multiplied by 1 is 2, and 2 plus 1 is 3. So I found my two numbers. Next step is to write those two numbers in brackets. So my first bracket and my second bracket. I've got x first, that's my variable, and then I've got plus 2 and plus 1. So I take my two numbers that I found here and I put them into my brackets with my x's. They're both positives here because both numbers that I found in my first step were positive. Positive 2 and positive 1. My last step is to check my work using FOIL. So I should be able to FOIL out these brackets and get the original expression, x squared plus 3x plus 2. So when I FOIL, I get x times x, which is x squared, x times 1, which is x, 2 times x, which is 2x, and 2 times 1, which is 2. If I combine my like terms in the middle here, I have positive x and 2x, which gives me 3x. So I have x squared plus 3x plus 2, and that's the same as my original expression, which means that my factorization in step 2 was correct. And I just did that exact same example, so we're going to skip that one. So if I look at this next example, I have x squared plus 6x minus 16. So my c value here, my constant term, is negative 16. My b value, my coefficient of x, is positive 6. So I'm looking for two numbers that multiply to give me negative 16. And those same two numbers have to add to give me positive 6. So if I look at breaking down 16, I'm forgetting about the negative for now, and I'm looking at factors of 16. I could have 16 multiplied by 1. I could have 8 multiplied by 2. I could have 4 multiplied by 4. Those are the only factors of 16 that I can think of. So because this 16 is actually negative, that expands my options here. I could have negative 16 times 1, or I could have 16 times negative 1. I could have negative 8 times 2, or I could have 8 times negative 2. I could have negative 4 times 4, or I could have 4 times negative 4, and really those two are the same. There's no difference between those because the numbers are the same here. Doesn't matter which one wears the negative. So if I'm looking at all my options, all of these options multiply to give me negative 16, but only one of them is going to add to give me positive 6. So think about that. Which set here is going to add to give me positive 6? Negative 16 plus 1 gives me negative 15. That's not going to work. Positive 16 plus negative 1, that gives me positive 15. Negative 8 plus 2 gives me negative 6, which is really close. Positive 8 plus negative 2, that's my proper option. Positive 8 plus negative 2 gives me positive 6. So my two numbers are 8 and negative 2. So now my last step here is to take those into the brackets. I've got x for my variable plus 8. And my second bracket is going to be x minus 2. If I FOIL that out, which I won't do now, I'm going to get x squared plus 6x minus 16. You should always check your work. I'm not going to save a little bit of time. Here's my last example. 3x squared plus 3x minus 6. And you should notice something right away that's going to make this a little bit more difficult for us, or a little bit different. You should notice that our a value here, our coefficient of x squared, is 3. It's not 1. We need it to be 1 in order to use product sum. You should also notice, because we've been doing this for a while now, that there's a common factor here between 3, 3x, and negative 6. And that common factor is 3. So I'm going to factor that 3 out. And what I'm left with here is x squared plus x minus 2. This is a quadratic trinomial that I can solve. So I'm looking for two numbers that multiply to give me my constant term, negative 2. And those same two numbers have to add to give me my b value, which is the coefficient of x, which in this case is 1. So I'll let you find those numbers, pause the video and find those numbers, and then check and see if you've gotten the right ones. So the proper numbers here are going to be positive 2 and negative 1. Positive 2 multiplied by negative 1 gives me negative 2. Positive 2 plus negative 1 gives me positive 1. So when I make my new quadratic trinomial in factored form, I've got x plus 2 onto x minus 1. And this highest common factor that I factored out carries down. And this is my final factored answer. So I want you guys now to go do the textbook questions that are posted on the board, not the ones from your workbook. Try the skills demonstration, and I will see you when I get back from Easter break and when you get back from Easter break. Enjoy your long weekend.